Hey everyone, in the last three sessions we have started with the properties of error function. In the next property we are going to find out what must be the derivative of error function of ax, right? First of all, let's try to write down the definition of error function of ax. See, note that I am having the definition of error function of x is equal to 2 over root pi 0 to x e raised to minus u square du. Using this definition, I want to find out error function of ax definition. Now, x here and upper limit is also x. So, in that case, ax is here. So, upper limit is going to be ax and all other things will remain same as it is. Whatever function appears here, the same function will appear as a upper limit for integral, right? Now, to differentiate this, we are going to apply Leibniz rule 2. Why rule 2? Because limits are as a function of this parameter, right? So, when I want to find out derivative with respect to x, so in that case x is a parameter and a is just a constant. So same parameter appear here, so this is the functions of x, that means I need to apply rule 2, right? So by using Leibniz rule, say rule 2, derivative with respect to x of error function of ax, this is nothing but 2 over root pi 0 to ax, derivative with respect to x of e raised to minus u square du, plus substituting upper limit in the function. So this is e raised to minus u is ax whole square will be a square x square into derivative of ax minus substituting 0 in place of u, so e raised to 0 into derivative of 0 with respect to x. So this is equal to 2 upon root pi. See, we are differentiating with respect to x. No x is present, only u is present. So this is constant quantity. Derivative of constant is 0. First term is 0. Please note that this thing is 2 over root pi is multiplied to each and every term. This is a constant, I am taking it outside. Plus this is 2 upon root pi multiplied by derivative of this is nothing but just a into e raised to minus a square x square, and next term is 0. So simply what we got here, 2a e raised to minus a square x square, and this is divided by root pi. So derivative of error function of ax is given by 2a e raised to minus a square x square divided by root pi. And that's it. I am simply applying Leibniz rule here. Similarly, I can find out integration of error function. So that is what we need to find out here. Integral 0 to say t of error function of, say, let's take same function ax dx, right? So I can write down this as 0 to t 1 into error function of ax dx, right? And now this is u into v. Let's apply uv rule for integration here, right? So this is nothing but this I'll consider for integration and this I'll consider for derivative, since just now we found out the derivative for error function of ax, right? So this I can write it as error function of ax 0 to t of 1 dx minus 0 to t d by dx of error function of ax into integration of 1 dx and the whole dx, right? And this is equal to error function of ax into integration of 1 is x and limits are from 0 to t minus 0 to t. Derivative, just now we have shown the derivative is 2a e raised to minus a square x square divided by root pi, and into here the integration is x dx, right? So let's simplify this further. Substituting upper limit, what we have, error function of, sorry, this is ax, so this is at into t. When you substitute lower limit, this becomes 0 minus 0 to infinity. See, I can write down 1 by root pi outside, and I can write down this as e raised to minus a square x square into 2a x dx, right? So let's start with the next part, right? Now note that here derivative of a square x square is nothing but given here, that is 2ax is when I'm differentiating this with respect to x, this will be 2a square just x. So just a square is missing here, 1a is present, so I'll just divide and multiply it by a, so that when I'm differentiating a square x square here, this derivative with respect to x is 2a square x, and already minus sign is there, so derivative of this term is given here as it is. That means its integration will be this term itself. So this is e raised to f at into t plus, because this minus sign I am considering here for derivative, 1 upon a root pi, and this is e raised to minus a square x square integration, and this is from 0 to infinity, which is nothing but t into e raised to error function of at plus 1 over a root pi. When substitute infinity limit, a raised to infinity is 0, so the term is 0. When you substitute 0 limit, I am going to get it, I'm sorry, the limit is t, I guess, yeah. So when I'm substituting t first, so e raised to minus a square t square and minus e raised to 0 is 1, correct? So instead of in t, I have written here infinity, so just note the mistake. Okay, so this is nothing but integration of error function.